गुड इवनिंग प्यारे बच्चों। तो अभी तक हमने मैक्सिमम ऑफ द थिंग्स रिलेटेड टू कैपेसिटर डिस्कस कर ली हैं। ठीक है, कुछ और बेसिक टर्म्स हैं जो अभी हम डिस्कस करेंगे। हमने यू नो व्हेन वी स्टार्टेड कैपेसिटर, ओके, वी हैव टोल्ड दिस पर्टिकुलर थिंग, वी हैव डिस्कस्ड दिस थिंग इन डिटेल कि a conductor has no electric field inside. Electric field inside. Yes. And I told you conceptually also. Okay. Now, so take it other way. Okay. Suppose we are having in this region electric field available. Okay. In this region, electric field is available. Above paper also in this whole region. And I am given a task. Okay, this point P is to be shielded from electric field. To be shielded mean electric field should not be able to influence this particular point. ठीक, तो मैंने क्या किया? What I have done, I have taken a body, a hollow body made of conducting material, okay, or placed that particular body in such a way कि ये point उस body के अंदर आ जाए, like this. In body is placed like that कि this point which we are considering that is inside the body, ये point P body के अंदर, ठीक. Another point Q body के अंदर, fine. So these P, Q and whatever point will be accommodated by this conducting body, by this conducting box, electric field intensity at that particular point, okay, कितना हो जाएगा after placing this conducting body? That will be 0. क्यों? Why? Because electric field inside conductor is equal to 0. Fine. Before placing this conducting body, okay, these points they were having influence of electric field. जब ये body यहाँ पे नहीं रखा था, जब ये box यहाँ पे नहीं रखा था, okay. Now what I have done, मैंने एक box made of conducting material यहाँ पे place किया, okay. As many points will be existing inside the conducting box, okay. Electric field intensity at those all points will be going 0, okay. And this particular property of a conductor, okay, जिसके कारण that conductor is able to, that body, conducting body is able to protect all the points which are there inside the conducting body from the electric field, जिसके अंदर वो points थे, ठीक है. तो this property of the conductor to protect all those points from the electric field, okay, in which those points are, okay, this property of the conductor is called as electrostatic shielding. Electrostatic shielding is the property of conducting bodies due to which they are able to protect all those points from the electric field which are existing inside them, accommodated by the conducting body. कहीं भी इलेक्ट्रिक फील्ड के अंदर कोई भी पॉइंट सपोज करो लाई कर रहे हैं, ओके, अगर आपने समहाउ वो कंडक्टिंग बॉडी के इनसाइड एकोमोडेट कर दिए, देन ऑटोमेटिकली उन पॉइंट से इलेक्ट्रिक फील्ड जो है वो एब्सेंट हो जाएगा, गायब हो जाएगा. मीन दोज पॉइंट्स विल बी शील्डेड फ्रॉम द इलेक्ट्रिक फील्ड, okay. Those conducting bodies which are able to do so, okay, mean all the conducting bodies in this case, okay, they are called as Faraday cages. Faraday cages, bodies which are able to protect the points in electric field, मतलब जो इलेक्ट्रिक फील्ड के अंदर लाई कर रहे हैं फ्रॉम द इलेक्ट्रिक फील्ड, ओके, इलेक्ट्रिक फील्ड से ही उनको प्रोटेक्ट कर दिया। और कौन से बॉडीज कर पाएंगी? एनी ऑब्जेक्ट विच इज मेड अप ऑफ कंडक्टिंग मटेरियल, ओके। नाउ polar and non-polar dielectrics. Dielectrics. Die mean two. Two charge concentrations. Okay. Now just see polar and non-polar. Now non-polar. Center of positive charge and center of negative charge. Both are at same place. जैसे हम सेंटर ऑफ मास की बात करते हैं ना, इन द सेम वे आई एम टॉकिंग ऑफ सेंटर ऑफ चार्ज। सेंटर ऑफ चार्ज बेसिकली ऑफ डाइलेक्ट्रिक, डाइलेक्ट्रिक मीन बोथ द चार्ज डेंसिटीज, center of positive, center of negative charge, both lies at same point. Separation between them zero. If separation between them is zero, dipole moment of this particular system will be equal to zero. So this is a non-polar dielectric. Non-polar dielectric. Dielectric. So dipole moment of a non-polar dielectric is zero. Okay. Polar dielectrics are those dielectrics in which center of positive charge and center of negative charge are separated by some distance. Center of positive charge and center of negative charge are separated by some distance. Opposite charge densities are separated by some distance, है ना? तो charge multiplied by the separation amongst the charged opposite charge densities, है ना? That is, this is making a dipole. So this will be having dipole moment. This system will be having a finite dipole moment. Dipole moment not equal to zero. It will be having a finite, and this is a polar dielectric. Polar dielectric. Now examples of non-polar and polar dielectrics. Okay, now H2, hydrogen gas, okay, O2, oxygen, fine, CO2, C, O and O on both sides कैंसिल कर देंगे, फाइन, ठीक है। देन मीथेन, बेंजीन, मीथेन, बेंजीन। On other way, if we talk of polar dielectrics are like HCl, okay. Then water is also polar, and so many others, okay. So try to find as many examples as fine. Now if there is any query in relation, okay, now send that particular query to me personally, okay.